situations that comes up in inferential statistics is when we're talking about confidence intervals and a margin of error is predetermined and wanting to meet that margin of error with a specific level of confidence. In those situations, the thing that we can deal with then is to adjust our sample size so that we're able to meet those requirements. So these types of questions are called sample size questions, and when we look at them, the wording of it's going to say how large a sample do you need, how many do you need to sample, find the minimum number to be sampled such that. Those sorts of wordings in the particular question are how you determine that it's a sample size question. Now with sample size questions, they could be kind of applied to whether you're working with the population proportion, the population mean, the population standard deviation, the population variance. And for each of those cases, there's different formulas or tables that you would have to either use or refer to. So the key to this, again, after you know that it's a sample size question, is to determine then what population parameter are they focusing on, and then for particularly the population proportion parameter, whether you have a preliminary estimate for your p-hat or not. In this example, we're going to look at a sample size question and talk through how we determine which formula to use and then carry out the process to find the solution to the question. So here it says, find the minimum number to be included in the sample. Find the minimum number to be included in the sample. It's a sample size question. So I know that I'm either going to use one of these three formulas or refer to a table to get my sample size. The next thing it says to be 88% confident that the sample proportion p-hat is within 0.05 of the population proportion. So now it's a sample size question of a proportion. In these three formulas, the very top one is the sample size formula for population proportion type of a question if you know a preliminary estimate for p-hat. The next one down is a sample size formula for the population proportion type question if you don't have a preliminary estimate for p-hat. And the third one down is your sample size formula for when you're dealing with a problem that is focusing on the population mean. So since I have a proportion, it's one of these top two, not the bottom one. So next up, I have to say, do I have a preliminary estimate for p-hat or don't I? When looking at the rest of it, it says, assume that a preliminary estimate for p-hat is 0.675. So I do have a preliminary estimate for p-hat, and it's for a proportion, so we are going to use this top formula for this particular question. So when we look at our n is equal to, and I'm going to write it here the way you might see it in some textbooks just so that you know what it means. So it's p-hat times, and sometimes instead of 1 minus p-hat here, they use the notation q-hat. So q-hat is 1 minus p-hat times the quantity z sub alpha over 2 divide by e. And that quantity squared is the formula that we need for this particular question. Now p-hat I know is 0.675. Q-hat is 1 subtract p-hat. So if I take 1 and I subtract 0.675, I get 0.325. So I've got those numbers. Z sub alpha over 2, we're going to get by doing some work with this information of the 88% confident. So when we're looking at the Z sub alpha over 2, remember that's the Z-score, so that when I look at the area that's left over from our level of confidence, I divide that by 2 in one of the tails. So you want to think of the normal distribution. The 88% is in the middle for your confidence interval sorts of questions. And when I take the total area is 1, take 1 minus the 0.88, and I get 0.12. That's how much is shared between the two tails. That's your alpha. When I take alpha and divide it by 2, I'm taking 0.12 and dividing by 2, I get 0.06. That's how much is in each tail. Now those are the areas, but you want the z sub alpha over 2. You want the z-score for which at that cutoff and you look at it, you have that area. So I'm really looking for the z-score on this number line instead of the numbers with the areas. Now to get that, when you have the area and you want the z-score, you either read the normal distribution table backwards, or you can look at like a TI-83, TI-84 calculator and use what's called the inverse norm operation. And the inverse norm, you find on the TI-83 or TI-84 by pushing the second button and then the button that is VARS on the top of the button and DISTR on the board of the calculator. And it's right next to the clear key. So if you push that sequence of the second key and then that button, you'll see different distributions under there. That's where you're going to find the normal CDF, the inverse norm, the inverse T, the binomial PDF, the binomial CDF, all of those operations. Go to the inverse norm. For some of you, when you push the key, it'll just give you an open parentheses. For others, it's going to give you a menu that says area, mu, and sigma. In each of these cases, the very first one here, or what you want across the area, when they decided to program this, it's the area entirely left of that cutoff. So if the entire area is 1, and I take 1 and subtract 0.06, then I would have 0.94 is how much is left of that cutoff, is if 0.06 is to the right. The other way you could think of it is entirely left would have to add up this 0.88 and this 0.06, which still is 0.94. So 0.94, comma, the mean is 0 and the standard deviation is 1. And when you do those keystrokes, you're going to get and then calculate the z-score of 1.555. So we have n is equal to, our p hat is 0.675. Our q hat, which is 1 minus p hat, is 0.325. Our z sub alpha over 2 is 1.555. And our E is in the problem, that's that margin of error that they have predetermined. So they'll either say with a margin of error of, or they'll say plus or minus this amount, or they'll say within this amount. So E usually follows the word within. And when I go back and I read this, it says within 0.05. So that's my E, that's what's going to go in the denominator. And then close the parentheses and you have a square. Now when you key this all through, you will get 212.181. But this is a sample size question, and sample sizes have to be how many you sample. They have to be a whole number. And you have to have enough in your sample so that you meet the criteria. So with these sample size questions, you need to round up, not round nearest, round up. So with this 212.181, round up, and it's 213. So that's the number that you need to sample so that you are 88% confident that your sample proportion p hat is within 0.05 of the population proportion p.